This is a presentation which I'm going to start by giving a brief intro about myself, and then we'll go from there. Uh, my name is Vijay Francis Lobo, and I work for IBM. It's been I have got almost like 30 years of experience where I have been doing firmware development, system software, doing a lot of code, trying to read the specs, kind of like dealing with lot of low level hardware. I also do a lot of specs. I am a senior IEEE member. Um, that's about it. And I kind of like love talking about the current presentation what I have. The sole reason is because this is something which I did from scratch myself out of curiosity, and I'm going to go each and every step. Then we will delve into more deeper understanding of what I really worked, what were the benefits, why I wanted to really present it. So the presentation is about UFS Universal Flash Storage versus the eMMC, and basically I'm going to talk about BMC boot storage. I will discuss about the performance, the architecture. If somebody is really impressed with it, they can always go do the migration, and I can even tell you that what kind of a migration planning you got to have, and what considerations you need to have. So let me start by giving a brief about BMC. So for every server these days, we got to have something called a baseboard management controllers. The reason for that is you cannot get the servers up and running the very first power on. So you got to have some low level firmware which kind of like runs and gets each compute elements and sets up the server. And once the server runs, you need to have something in the background trying to monitor the server. So my specialization is in baseboard management controllers. I've been in this field for almost like 20 plus years, and we kind of like have various types of BMCs, but I'm going to really talk about OpenBMC here, because that is kind of a standard. It's kind of one of the it has got a release cycle like your Linux device drivers, which we get a lot of stuff for free, and it is kind of open source. And I'm going to really compare the functioning of universal flash storage with respect to the embedded multimedia card. So when we think of the current BMCs, we got to make sure that we really support a secure boot. Like there are a lot of TPMs, there are secure elements, secure code, and the boot code has to be really very secure, right? I mean, you cannot have something out there which is vulnerable to hacks. Like anybody can come and hack the code up, or they can even get into your enterprise server architecture. So you don't want to do that. So you got to have secure boot supporting a lot of cryptographic functions. And apart from that, we got to have something called Redfish APIs we use, basically a web interface where you want to do the management of the servers. We used to have our own web interface trying to connect through the HTTP server, but we kind of like tried going towards Redfish API because it's kind of industry standard, and the motivation for that is to make sure that the OpenBMC core what we put out for general public, they can use a standardized Redfish APIs and they can do the management of their servers. And one important aspect of this is trying to do the telemetry services, right? When you try to, as I said, when you try to boot servers got to power on, and we got to monitor for error conditions or platform error logs, trying to read them, trying to decipher what the errors were, whether we can fault isolate, we can replace the parts, like you can do a hot replacement, like a hot plugging and stuff like that. And even current BMCs are faster that way. We can even do a parallel initialization of the system boot. the system boot really takes time. When I initially started working on this area, where I used to sit and wait for the management controllers to really boot up a system, which would take anywhere from a hour 45 minutes to 2 hours, and I used to patiently sit and wait for that. But the modern day BMCs go really fast. I have time comparison, so we can really talk about it. So as we progress, we can see the differences, the benefits of the universal flash controller. And this presentation is basically trying to compare universal flash controllers as opposed to embedded multimedia cards, which we currently have. Moving on, let's understand the storage landscape. How the I'm really talking about like a 10,000 feet high overview. I don't want to delve into nitty gritties of the hardware. Uh, it kind of like makes sense when someone really figures out, okay, so is it the right thing to do, right way to proceed, right way to really make use of UFS? That's when you have to really go down deeper and try to understand the hardware. So for this presentation, I'm not going to go down at the protocol level. I'm going to go very high level. So eMMCs are kind of parallel. They are half-duplex interfaces. So that's kind of like a bottleneck. And there is no native command queuing support for that. It kind of like hinders the speed. But the ecosystem is wide and a lot of people adapt it, and it's kind of very matured. And since it's half duplex, it's does not have any queuing system. It's kind of simplified. Whereas when you go to UFS are pretty much like they are serial. You can compare that to PCIe's, like how popular they are now. And this is a full duplex interface. They use this MIPI mobile interface protocol interface, and we do Pro standard and down under. It's kind of like very solid frameworks to really try to use this full duplex design. And we do have something called a concurrent command execution capabilities, which really make it faster. And it's also standardized by JEDEC spec. The experiment what I did here was I was using a JEDEC version 3.0, and they also released a 4.0, which is kind of like MCQs, which is a bit faster as well. This is a bit complex when you want to implement it because of the queuing, because of the command structure. It's a full duplex. You have to maintain all that, so it's kind of a little bit complex. So it costs a little more. We will talk about it in the future slides. So now, when you want to really compare, I'm just trying to kind of like go a little bit deeper in here. We have this data, the half duplex mode. The half duplex always creates bottlenecks, right? Because when you have eMMC running in half duplex, you got to transfer your commands and data in the same bus. That really creates bottlenecks, and the IO operations are not fully sequence. What do you say? Like you are not kind of like exploiting the real hardware benefits here, because there because of this half duplex, it always ends up in problems. Okay. And but UFS is a full duplex. You can do a bidirectional transfers. The command queuing is pretty good. So we can do multiple operations, as I spoke already. Now, UFS offers sequential reads. They have got this. The read is very fast. Then you can do a real read and write of the file system really in parallel. You can run multiple queues at a time. I'm not really going down to that level, but that's pretty fascinating. If you read the JEDEC spec, it will just explain you how to do it. The command queuing for UFS allows to the random IO patterns, trying to really run them in parallel. Everybody talks about, it's always good to have a full duplex, and enterprise servers have many computes, and the hardware is in the magnitude of like a few. The system which I use has got like at least 1,000 compute, and compute processors, and it has got like at least some 64 terabytes of memory. So you can imagine if you were to use a half duplex, a slower BMC, so how much time it's going to take to boot the system. Moving forward, so what UFS does is it has got a dedicated command line interfaces. Then there is something called the low-level buses. They don't switch between low-level buses. So we have got like a dedicated command and data phases. We have got dedicated buses which have a hardware mechanism where they can transport the packets over the MP5, the Unipro low-level layer, and the throughput is very high because you can go almost like 32 queues, and the queues are going very deep, so you can have all these queues running in parallel. And the serial interface design of UFS, that to scale bandwidth, they are more efficient across the technologies. So this is very pretty important. When I talk about enterprise servers, which I deal with day in and day out, all I care is like once you have a hardware being implemented with a software, I want it to be reliable, and I want to do error isolations, right? And for UFS, the error detection and the corrections is very high. Like the whole hardware protocol is built in such a way that the errors can be mitigated much better than eMMCs. So the UFS has got a reuse of SCSI. You don't have to really go reinvent the wheel. So what has happened in the UFS is you have all this reused BP layers and the protocols, and at the low level, when the real commands go down to a logical unit where you literally read the data and write data, the real NAND flashes. So we basically use SCSI commands. So it's kind of like handy. Even SCSI is very well accepted in the industry, and a lot of people know about it. It's kind of legacy, but there is a not a full-fledged list of, I believe, like 60 to 70 commands. This one is like kind of like shortlisted to 20, so which are very widely used. And so that is one part. The other fascinating part is the UFS has got a very good mechanism to maintain these low level NAND flashes. Like you know that it has got like limited write cycles. They can wear out really fast, but UFS has got mechanism to really manage them pretty well. So there are some power levels. You can just go low level in the power. So there are a lot of features which if used efficiently can really boost the life cycle of your system. Let's talk about a little bit of the complexity and integrities of UFS hardware. As I was speaking about the mobile industry processor interface, the M5, the hardware, which basically takes the packets across from the controller to the responder. It basically uses, as I spoke, it's a Unipro protocol. I generally don't deal with Unipro protocol. All I do is like I package it since the hardware is already available off the shelf. So I don't do much of protocol implementation. I'm kind of like one level higher in the software layer. So the hardware, because of the lower level complexities, we got to have a controller which hosts on a system, and controllers are basically we drive it from the Linux interfaces, and they're kind of a little bit complex when you compare to eMMC. And because of the way the multi queues, the packets we have to deal with, there is a task management package. There are this real data transfer packets. There are like two sets of packets we have to deal with. So, and as I spoke, there are multiple power states you can control. It has got advanced error recovery, as I spoke, and because of all this added features, your software layer becomes a little bit complicated, But the good news is I was basically using a Samsung driver, and it is off the shelf. So somebody wrote for us, and that works pretty well. So I do have a small snippet of the hardware, how the boxes down, which basically say, okay, there is a server sits there and trying to listen to the commands coming from the host. So host is nothing but your BMC trying to have some application code which basically transfers the packets across using the M5 interface and the UniFlow protocol. So you can see that there are these 32 or 256 logical units you can have, and they are all independent units. Like they have task management stack. They you can application can run the real data. You can go read the NAND flashes if there is one of the logical unit is not working. So you could always have more than one logical unit to really serve your purpose, right? So you can have like one logical unit having your secure boot code, or you can have, if what if that is corrupt, so you can have one more backup secure boot code, or you could have one more logical unit to really do a file system management. There are a lot of features and flexibilities here, and the capacity wise UFS can really scale up. So now going forward, this is a nice picture which I generally like to really demonstrate and show like at the high level. Uh, so let's move forward. Now let's talk about a little bit of the cost and scalability. As I said, eMMCs are pretty much widely accepted, right? They have been there, they are there in the industry, and they are kind of like cheaper. And there are a lot of people who supply eMMCs, and the prices can really become competitive. Like you probably pay like 20 cents per gigabyte, and they are pretty solid. They are pretty stable. They are kind of cheaper. They are easier to use. Uh, so they have been there in the field for a long time. When we go to UFS, it's kind of like a fairly new, so to speak. I don't say like it's very new. Like there is a good amount of adoption right now, and a lot of mobile phones use it for the higher end mobile phones, which need more capacity, faster access times, and more secure boot code. So one way it is kind of like a little bit higher, and vendor ecosystem is kind of evolving now. I believe it is kind of like matured enough now. We could just go and use UFS. Cost I see for my personal opinion, I see is kind of like a little bit on a higher side, not too expensive. So, but when it comes to the server grade, which I really use, we need a piece of hardware which is very reliable, and you can isolate errors, you can have redundancy. I talk about RAS capabilities, reliability, accessibility, and serviceability. So I basically, when I try to look for a vendor, so that's what I look at. It's kind of like probably ballpark figure of, like, you can say like I probably would go with a part which is 30 cents per gigabytes, and I don't think with the current market, so they are anyway expensive. So the one good thing about UFS is it's still evolving, and with the current standard, I feel it is very good to use and to consume. And I don't think the price really matters. If you ask me, I don't think this is really expensive for all the features and benefits what you get. So let's talk about the technology direction now. So eMMC is matured, and they're kind of like slowing now because you don't have higher capacity, right? And security wise, there is a issue. There is no error correction mechanism inbuilt. It's kind of like this. I can feel that it is slowly fading away. And since the UFS is kind of like standard, it's really picking up the market, and it has got a strong, long term, long haul hardware it is, and I'm pretty sure so that is going to stay for much time in the future, and you can always go enhance it. So generally, for the servers, what I've seen, they are increasingly adapting UFS as opposed to eMMC these days. So the for all the features and benefits which we spoke about, I think that is where the industry is going. And since the more number of people come in, they input more. They kind of like give more info to the standards to evolve, and it's kind of like good because we get better products when there are more people consuming it. Let me talk about when I kind of like did this is how I really started picking up the spec, and I said, okay, so you know what, like I need the motivation was like I have this BMC and I need my BMC to really perform well, where I need to have secure code, and the code base become really much bigger because I had to put a lot of applications in the code. And eMMC kind of like had a limitation for me, which said, okay, you know what? So this is the upper limit. We cannot really scale it up. Now the applications are more, and the servers became more and more complex with more computes. Because on the server side, we have probably like I have like almost like 1,000 full-fledged power PC cores, high-end cores, and I have got a lot of other compute units, like trying to control the power, trying to do a smaller processing. Then there are other GPU kind of units which do like accelerator functions. So there were so many computes coming in, and we had to program. Then the memory really increased, the RAM, the system RAM, it, it blew up. So it went multifold. So I could not really afford to have older technology, and I had to really figure out like we got to move forward and adapt some newer hardware. That is when I said, okay, so let's go try this UFS, and I basically used the UFS standard 3.1. And what I did is like since I did not have hardware, so I'm a avid user of WinRiver Mix, and I like Semix because you could go model a device, and I could use it, right? I can, since I have this OpenBMC, I can go see what drivers are available. Then I just go bundle it up with my firmware, flash it on my my system, so to speak. Like if it's a simulation, I just load that into memory and I start off. You can see for a real use case where I had eMMC, which was almost like 128 MBs, and that for the same server, I'm having exact apple to apple comparisons. I had same compute units and the server side of units. It took almost like 20 minutes in the simulation with a very minimal configuration, right? I don't have a full-fledged 100% loading high-end system. I have very minimum one processor, few compute units, and it almost took like 20 minutes for me to really boot. I took the same thing, then I used the same piece of code, bundled it up, used a UFS file system, and I started loading it through UFS. That booted BMCs in 5 minutes. You can imagine if considerably if the firmware increases or the boot code is, we can add more apps, make it we can add more security features, even we can do parallel, we can extend our parallel load times, right? So what I can see here is eMMCs, the moment there is more code, there are more compute, the system becomes complex, the time can go further up, right? So in the magnitudes of like what, 10 minutes added to 20 minutes, 30 minutes, 40 minutes kind of a thing. But here we have a scope to parallelize. So I'm pretty sure, so relatively the time consumed to boot with respect to UFS is going to be much smaller. And you can see the capacity is almost like 15 gigabytes. And everything was set up. The results were very good. So I did not expect it to go this far. It kind of like booted like almost like 3 to 4 times faster. So this was an enterprise system with a lot of complex firmware. It had all the secure boot, the firmware checks, then the multiple services we wanted to start. Everything came up within 5 minutes, and that is amazing. I would not expect anything would run at that speed. So I was impressed. So that's the reason I said, okay, you know what? This is something which I have to educate people and bring it up front. And I also said, okay, I'm going to publish a paper with all my findings. I have even seen certain presentations where they were talking about UFS boots are faster, like 2 times faster or 3 times faster. Like, but I wanted to really go see it for myself. So that is the whole reason I started venturing out, and I really, really saw it much better than 4 times, right? So that's what it is. So let's talk about, like, if somebody thinks uh, they don't care for a few cents of differences with the price for better hardware. If they want to really migrate, here is a consideration, the migration consideration, right? So what you really have to think about. So the first thing first, your hardware is going to change. You got to get a different stack, and you have to have your different controller. You got to think about the signals and power, and once you do that, you got to get a firmware driver. So it's not very simple to really write from scratch. You cannot, if you want a bug free, you got to go and get it off the shelf. So, but luckily, as I said, there is already a Samsung driver which I could go use it, and that really worked well. Okay, and that's the reason I was just trying to say it is already available. It is tested, and I believe when they made it public, it was tested with, and they had a pretty good test cases, and I saw the driver looked pretty good, and it did boot for me, performed pretty well. And test wise, I kind of like did my simulated version of logical units. I just had 2 logical units, and you can extend as much as you want, right? I mean, depending on what kind of capacity you want, you can just go get it from the vendor. And it's kind of like testing is pretty good. The hardware is reliable, and when I did like multiple iterations of boot, power on, power off, so I did not have any issues at all. Everything was good, and the only thing you have to worry about is like a supply chain, how and where you want to procure it, and who is the vendor, and how much you want to shell out, and what is the capacity. But I think it is, for me, what it feels is like it is very much matured now, as opposed to like probably like a few years back. So it was kind of like a evolving field, but now people have realized that this is something which is of high benefits, right? Even going in future, if you want to go back to eMMC, I'm pretty sure it's going to be like expensive than UFS. But as the current market goes, UFS is slightly more expensive, but you get there is a better trade-off, right? So you get a lot of benefits. And I just wanted to say that the entire presentation, what I have here, is evidence-based. Okay, so eMMC, if you want to really go for the current systems, you want cheaper, go with it. It's cost-effective. It's only for near-term benefits. But for next generation, I would recommend use UFS, which is sort of matured, uh, pretty stable, and the firmware can run multiple life cycles. So you can do a lot of flashes. NANDs are pretty good, good power. So I would certainly recommend all the organizations to really go evaluate UFS, and it all requires is like little bit of risk management here, and I believe the technology wise, this is far ahead. So I kind of like, this is my personal opinion, and if I'm asked, I would say always go with UFS. So the key takeaways, uh, UFS boosts performance, the context of what you want, that really drives your storage. For UFS, you need to have planning. You got to have an ecosystem to transfer from file system, eMMC file system, to UFS. You got to have a packaging done. You got to take care of the scales and complexities, and you got to take into consideration. So all this evidence is what is being presented over here. So this is my final slide. So what the study demonstrates is UFS in any case, in any day, outperforms eMMC boots, whether it be IO concurrency or long-term viability of hardware. It has got slightly higher cost, but I still feel it's much cheaper. If you ask me, it is much cheaper comparatively for all the benefits you get. So pretty much all enterprises are leaning towards UFS. Boots much faster. You can, as the stack becomes more complex, your speed is going to kind of remain the same because you can do a lot of parallel uh, processing here. So you can go read parallel packets. So I just feel that it's an incremental change, and I believe in future all the BMC based systems, or for that sake anybody trying to use their own in-house built management controllers, they could just go get it from a vendor and start using it. So that is a final slide from my side, and I thank you all for listening to my study between eMMC and UFS. I'm not pretty sure how, since it's not a live session, I don't know how many questions are there and how clear I articulated my concepts. But overall, I am very fascinated about UFS being one of the best things I've ever looked at recently. So any questions, you can always mail me. My email ID and everything will be shared from the. I believe there is a group of people who are going to host this, and they're going to share all my contact information, and I'll be happy to help you out. Thank you.